Okay, first thing we'll see new features or the differences that were added in 12c, changed in 12c, especially from the point of implementation. There are a lot of changes, small minor changes kind of thing, internal changes, but all of them will be too much internal, but we will see more noticeable features or noticeable changes that actually were implemented in 12c compared to 11g. 12c is actually after 10.3.6 of WebLogic. Now there is no 11 version, so you got 12.1.1 and 12.1.2. That's release 2. That's even between 12.1.1 and 12.1.2 there are a lot of changes, but not that much. So the 12c itself is having some additional features that 11g doesn't have, and there are a lot of bug fixes that were there. So all the clients at Oracle recommendation is to if you are starting it new, directly go ahead with 12c instead of 11g 10.3.6. 12c has better features, better stability, less bugs. So that's a recommendation from Oracle. So we will see what are major changes or major features that were included in 12c compared to 11g. I mean at the 10.3.6. Now if you observe, this is not a specific order as such. I've just included the changes as I came across them, went through the documents. This is a new component that was added in 12c, Oracle Traffic Director, but this is front end to WebLogic, not the WebLogic itself. 12c will include what is called a web cache, which is currently available. If you see a typical architecture, just give me a moment. So normally if you see current architecture is like you have WebLogic, like this, alright, and then you have Apache HTTP server, and in front of Apache HTTP server there is a component called web cache. Now the web cache, usually what it does is it stores the frequently accessed pages. This is web cache. After web cache, usually you have Apache or Oracle HTTP server. This is then you usually got a WebLogic server, app server. This is the current architecture. Now this web cache is gone. Now the web cache, now if you see, depending on the architecture, the Apache web cache layer is basically for static content. But if the static content itself has too many requests, instead of Apache going to the hard disk every time to fetch a page, it stores it, it buffers it in a web cache component which is in front of Apache. So the static content request, which is very frequent, gets served from the web cache itself. Now the web cache is gone. We got a new component called Oracle Traffic Director, and that actually takes care of redirecting or integration with the WebLogic app server. But still we have OHS, Oracle HTTP server, and the integration will also be available. And apart from this, a more noticeable change for WebLogic in 12c is its connectivity or its integration with the database. Now it is heavily integrated with database, and it now depends on the Oracle notification service and what is called the grid link to basically give super failover and load balancing across the nodes of a rack. Earlier you have what is called a multi-source. Now the multi-source is still there, but instead of depending on purely on a multi-source, to load balance across multiple nodes of database, which depend more on ONS services. That gives pooling, that gives session affinity. Session affinity in a sense, if node 1 of a database is currently connected with managed server 1, it's very likely that node 1 again will connect to managed server 1. That's a kind of session affinity, so that you don't have to recreate the session, just like your HTTP, what we call stickiness, the session stickiness. The same thing now available in at database level. That's one noticeable feature. Now what Oracle claims is because of those features, it improves the speed almost 3 times. So you have a much faster connection between WebLogic and database now in 12c compared to the previous versions. Now this is probably a second edition. Now, apart from this, these are some of the additions that from a developer's perspective, HTML5 is included. That includes annotations, and I think because of the annotations, what they say is the number of XML lines coding will reduce. I'm not really sure how that would impact the overall this thing, but I just picked up a couple of lines from a developer's perspective. Now obviously macOS support is there, that was not there earlier. And apart from this, there is another type of installer now coming along. Earlier there used to be a single installer kind of means you got a 700 MB or 800 MB installation. Everybody have to download it and they have to use it. But this time in 12c, just for developers and for quick download and installation, it comes as a very lightweight installer, about 200 MB or 168 MB, that developers especially can download and start testing things. That's these are a couple of things that the developers might be able to like. Apart from that, there are some new features I've added, and this is a very nice article here. I'm going to send you this PPT, so make sure you go through this article. It really gives you a very nice new features of 12c kind 50 minutes. If you go through it, what happened? Plugin not supported. So this is a very nice presentation by it's all new features. It's more of an interactive. Included some of the points from the presentation as well, so the important points. But it talks about a lot of other features that are in internal features. Just make sure you go through that one also. I'm going to send you this PPT after we are done with this. Apart from this, there are a couple of other things. This might be from a administrator perspective or an architect perspective, how things would change a little bit. Now earlier you have each installer was kind of platform specific in 11g. If it is a Windows, you download Windows. Then if it is Unix or Linux, you download Linux. Now there is no platform specific installer. They're all generic installers. Means you have a jar file, that's it. So first you download the JDK, you install your JDK, then use the same jar file for installing anywhere. This generic installer was available in 11G also, but apart from the generic installer, you have platform specific installers also. In 12C, the platform specific installers are gone, so you have only a generic installer, which means installation has to be done. First, JDK you must install. On top of JDK, you use the jar file to install your WebLogic. Apart from that, the zip installer I told you, which is for developers, that is another installer. Now, apart from that, earlier you used to have bsu.sh. This is an upgrade tool, BEA Smart Upgrade tool, or BEA Smart Upgrade Utility. That's what used to be called. If you see on the server, it's usually under utilities directory. Excuse me. So if you see, pick up any of our BEA installations, BEA 10G. Go to utils, tools. You see BSU there. This one. This is actually the upgrade utility, BEA Smart Upgrade. That's what it used to be called. Now the Smart Upgrade is gone in 12C. The BEA Smart Upgrade is gone. It's changed with what is called OPatch. OPatch is will be available. OPatch is a much simpler tool. It's already available, OPatch, but bsu.sh was also available in 11G. So now it's completely gone, the bsu.sh, and OPatch is the one that will completely take care of patching, upgrading, everything, a single command. All that you have to do is, yes.
When you said about the Mac OS, you meant from the client side, right? As a client, as a browser, now the Mac can use this WLS application. Is that what you meant? Or you meant as a server? That
as a server,
as a server. The WLS server.
As a server,
I see.
Servers, yeah. And yeah, so the BEA Smart Upgrade is gone. Instead of BEA Smart Upgrade, we only have OPatch now. That's from an upgrade perspective, especially for an administrator. Now the cluster thing is more from an architect perspective or implementation perspective. This is probably the most noticeable feature that were included in WebLogic. A dynamic cluster means now if you observe now till 11G, you have the number of managed servers in a cluster are fixed. Means we create a cluster, we add servers to it. Those number of servers cannot be changed during the peak load or anything. What this dynamic cluster does is you define the number of nodes. Let's say if the load on the existing servers is reached a threshold, you can define in a way start a new node or start a new managed server instance. So a dynamic cluster, you will simply define the number of managed servers in the dynamic cluster, and WebLogic will start up or shut down managed servers automatically depending on the load. So it takes a template. We define this dynamic cluster and we define a template based on which it should create those managed servers, obviously. So the feature is you have more load, WebLogic automatically kicks in a new instance. The load goes down, those servers, that server will go down. So that's a new, which is not available feature, completely added into WebLogic. So if you see probably the corresponding change in your admin console, you got a dynamic cluster here. Earlier you have clusters. In clusters, now you have a couple of new clusters. As the regular cluster and the dynamic cluster. Dynamic cluster is where you define the number of max number of nodes during peak load, That way WebLogic automatically starts new nodes when required. So those nodes will go down once load goes off. This is one probably the most important feature that is not there in 10.3.6 and which is available in 12c. Apart from that, there is a grid application, GAR application it's called. It's a grid application archive. This is a new type of application, especially for coherence. If you see, a coherence is basically a replacement for Oracle HTTP replication. If you remember, we have talked about HTTP session replication in WebLogic, and WebLogic itself using a cluster provides HTTP session replication. That is for static content. Now what JSPs pages, sorry, not even static content, JSPs, let's say, and JSPs and servlets, that's HTTP session replication. Now what coherence does is a similar thing, but at a much higher level. Means you have replication for all types of Java objects. Basically, coherence as a it's a product actually. So the product comes or gets installed on top of WebLogic as a separate layer, and that layer provides all this high availability. It takes care of the session replication. WebLogic cluster does not have to explicitly do that session replication. The coherence as a product, which is sitting on top of WebLogic, takes care of this thing. Now, such coherence applications can be created, and they will be usually bundled into a grid application archive, which is a GAR file. Now, the GAR files, again, they can be bundled into an AR file or as a separate .gar file. That's a new application that can be deployed to the entire coherence, what is called the coherence grid. So if you have a coherence application, now the question is, do we want a coherence grid on our environment or not? Coherence grid is, think of coherence grid like this. Instead of HTTP session replication, you are installing another product called coherence that gives better features. Means unlike HTTP session replication is a very basic form of failover, whereas coherence is a very high availability. Means you can add, delete nodes on the fly, just like a dynamic cluster. It gives better features than regular, very simple HTTP session replication. Now, if you are implementing that kind of coherence, high availability, you may want an application to use those features. So if you are developing an application which wants to use those coherence features, that application would be bundled into a GAR file, a grid application archive file. So that would get deployed to the coherence layer of WebLogic. Coherence is a Java product. It's a Java application, sits on top of WebLogic. Alright, so then a couple of more. Again, this is a minor feature change. Response file, instead of a response file, the silent installation we had, which actually uses silent underscore XML. Now you have a response file based installation, just like any other Oracle installation. Now, Oracle is trying to unify all types of installations into a single model. If you observe, all Oracle installations include a response file, especially the database, and nowadays SOA, OSP, all those things. All of them use a response file model. Now even WebLogic comes with a response file model, just like silent XML. Instead of passing a silent XML, you pass a response file now. Now another thing is upgrades. The name has been changed. Earlier there is an upgrade wizard that we're going to use upgrade wizard to upgrade our WebLogic from 10.3.0, which we are running currently, to 10.3.6. Upgrade wizard again is a binary file, bin file. You download it from downloads location on Oracle support area. Once you download the upgrade wizard, you simply run it. But the upgrade wizard is gone now, and it's called reconfiguration wizard. Apart from that, node manager is another thing. We will talk about node manager towards the end of our sessions. Node manager is outside WebLogic domain. What it does basically is it monitors WebLogic servers. It makes sure the health of the service is good, and the most important feature of a node manager is it can automatically restart WebLogics in case they fail. Or that's the most important reason why you would implement a node manager. It will for automatic crash recovery. Then that node manager earlier used to have, now we currently have it at what is called your entire BA installation level. You have one installation, one node manager will take care of all the domains coming out of that installation. And now what has been changed is the node manager is at a domain level. You will understand this feature more when we talk about node manager in our own sessions. But earlier it's at installation level, now it's individual domains level. Means if an installation has 5 domains, you run the config.sh 5 times and created 5 different domains, then you pretty much have 5 different node managers this time. Then the cloning thing was introduced. Cloning is already available. It's not that cloning is not available, but a new WLST internal command was added to clone the managed server from command prompt. Otherwise, managed server cloning is already available from console. So instead of along with console, we also have a cloning thing from WLST. So this is a dynamic cluster part. This is from a database perspective. Oracle database is now very tightly integrated with 12c. It's pretty much like a package. Grid link actually is now available. Grid link is what it uses the Oracle notification service, ONS. Instead of a listener model, we have a ONS model now. ONS model basically provides the high availability across rack nodes. It has other features like these 3 features. I'm not really sure, or didn't go deep into these features yet. They sounded more like a database and a concept. Probably I'll go through them sometime later, but if you get time, see what these features are from a database perspective. Application continuity, DRCP pooling, global data services. I'm not really sure what they mean at this point. I still have to go through them. It looks like some additional features from a 12c perspective, but I'm not really sure on that part. So these, the idea of having these additional features is to provide a very high level of failover in terms of WebLogic to database connection. That's the purpose of all these features. It's, the integration with WebLogic and database now is it's a kind of 100% fail proof. That's what all these features actually aim to do. And obviously you have got Oracle database 12c support and 12c of WebLogic. Apart from that, JDK also is 1.7 supported. So that's from a JDK perspective and a database perspective. And this is one change probably you might already understand. If you observed yesterday, the day before yesterday, the GMS servers we have targeted to individual managed servers. Now the GMS servers can be targeted to a cluster in 12c. That's one noticeable change. because even though it's the JMS server is targeted to a cluster, you have individual instances of JMS server everywhere, and each of those JMS servers will have a corresponding persistent store. It will try to do what is Deepak, as you said, it's better if we have a common storage. You can pick it up and write it to the same storage. We are actually moving towards that kind of setup. Currently, it's not at there, but once the JMS server is targeted to a cluster, basically we will move to a storage method wherein multiple JMS servers can write to a single persistent store. That's a model we are trying to move to. So what I would say from a 12c perspective is the features perspective. Most noticeable features on a daily basis would be uh, a dynamic cluster is the most important feature. Apart from that, if you have upgrades, that would be a O patch instead of bsu.sh. That's something that you commonly do. And then you would have a coherence application, a GAR file newly introduced. Then these are developers related activities we are not really are not visible at least. And you will have more integration, a better integration with Oracle database. So overall I would say it's much faster. That's what I would look from a overall perspective. It's WebLogic is much faster, especially when integrated with Oracle database now. It integrates better, it performs faster, and couple of changes in terms of availability, especially because of the dynamic cluster, and support for the latest JDK, the 1.7. So that's what I'm seeing 12c offers.
Anil,
Yes.
Anil.
Yes.
Is 12c is meant for the cloud version, right?
Yes, 12 cloud. That's right.
So I was eagerly looking for the where this I mean at which layer this cloud is getting supported. So what part is supporting for the cloud in the WebLogic?
Yeah, that's a nice question. That's not there actually. It's still the same.
Okay.
There's no cloud convince that changed features or anything that are currently not there and all of a sudden we are including. No. It's more like it works like an application grid kind of thing. So cloud in a sense, the availability in terms of let's say coherence is probably one way of saying it's in cloud, but that's already there in 11g, so not exclusive to 12c. Coherence what makes WebLogic behave, look like a cloud server, cloud app server, because of the high availability that it provides. But other than that, there is no specific feature that's added only in 12c that's making it like cloud. One noticeable feature I would think is a dynamic cluster.
Okay.
Other than that, not very much like a cloud feature that we usually see.
So Oracle coherence, Anil, is new in 12c or was there in 10.3.6 also?
It's there in 10.3.6.
Oh, it's there.
Yeah,
So
it's there.
it has been there. It has been there. So it's not new, anything like that, eh?
It's not new. It's not new.
So was it there before 10.3.6 also, or it was
It
only
was
in
there from
10.3.6?
10.3.3 onwards.
Oh, okay. So that's not something new, huh? Okay. Okay. Thanks.
Then so how it's providing the features of cloud then? So apart from this Java J2 applications and Flow applications,
Mm-hmm.
so the how it is going to serve the cloud applications then?
WebLogic.
Oh yeah.
No, you mean that was not done in 11 and that was not done in 10.3 and was done in 12c.
Images.
No, there is no noticeable difference. It's same. At 12c is more like we are moving towards cloud. That's it. But the cloud features were already there in 10.3.6.
Okay.
The features were already included before 12c itself. 12c does not come with anything exclusive except for the dynamic clusters. And obviously you will see a better integration with database. That's guaranteed.
Okay.
On the on the
No,
back end, you have,
I'm not sure about cloud does what it will do. I don't know.
it
So,
won't do anything. It won't do anything.
okay.
As no difference that 10.3.6 is giving and 12c, 10.3.6 is not giving and 12c is giving in terms of cloud. Nothing. The name change was to gradually take you towards the features that were already included. Means cloud features were already there in 10.3.6, but nobody says it's a cloud. By putting 12c at the end, now you started thinking, okay, WebLogic is more like high available cloud server, but the features were already there in 10.3.6.
Okay. So high availability and failover. So some brushing up these features is called as cloud or what?
What is it? Sorry, brushing
No,
up.
no. So yeah, meaning I mean improving this high availability and failover.
Yeah, in a cloud, that's what we usually see, right? Whenever we say a cloud server, we basically look at the availability.
Okay.
That's what a cloud usually means. Means your server is available anywhere, so you can simply use a simple connection to connect to a group of servers. Any other points that we can discuss?
I think I was thinking like it will provide a better storage.
Yeah, that's what I've seen these features, but not too many changes, not too many you know, new add-ons. So it's nothing that all of a sudden a new product was released and you have to learn it. No such thing. It's there. There are small
Okay.
improvements. That's it. The features are already there. But there are a lot of
Right.
bugs in 10.3 versions, means 10.3.6 or 10.3.5. If you see, they're all patch sets. 10.3.1 to 6, they're all patch sets. So basically, there are a lot of bugs in 10.3 versions. So all of them have been, ironed out, and you have probably a fresh code in 12c. That way, it improves the overall performance.
Okay. Instead of saying cloud version, we can say coherence version.
Yeah, you can say that. Yes, coherence is the main thing that is probably putting this version into cloud. Alright, so I'll send this PPT to all of you guys, just in case. Let me send you that PPT. Okay, now let's get into our we're going to see SSL today. SSL is a very interesting topic, and this is generic SSL. It has nothing to do with WebLogic at this point of time. Once we understand what is SSL, why we need SSL, then we can configure SSL for any product, not just for WebLogic. We will also see how to configure WebLogic, because that's a specific product we are looking for at this point. So we will see why we need SSL first, and then the generic way of creating certificates, creating certificate signing requests, what are identity stores, what are key stores, all those things. Now all those things are generic, means any SSL anywhere you do, it's the same thing, it's not going to change. And finally we will see how to set up SSL for WebLogic. Now first thing first, why do you guys think we need SSL? A secure socket layer. Give me a couple of answers at least. I will know what exactly it is that you are thinking. Why we need SSL?
For a secure communication.
Okay, secure communication between client and server, let's say, or two applications, let's say. Okay.
Right. Yeah.
Anything else? Secure communication in the sense, what do we mean, Deepak? Can you elaborate on that one a little bit? What do we mean?
Say for example, a simple example of that could be that if a client has opened a communication with the server, at that time he can ask for anything. So before even ask, first of all it has to get authenticated. So the moment it gets authenticated, it has to create a separate dedicated tunnel with that server application. So that's the word I'm using here, a dedicated tunnel, and wherein it makes sure, the server makes sure that it is sending or replying back to the same user session which has initially requested for it. Right? A very good example of that could be, sometimes when we go to website these days, it gives us some very jumbled up characters to put in there and send it back, right? That's a way of implementing it. It is not SSL at all, but it is a way of implementing just to make sure that there is the same person able to reply back to me, so I'm not answering back to a machine or a proxy.
Okay, yeah, fair enough. That's pretty much it. Yeah, I'll put it in a much simpler words to give you a better understanding. Yeah, thanks, Deepak. So here, let me start with an example. Let's say you logged into one of our sites, any of our sites that you usually work on. Let's say something like ebay.com. Let's say you've been browsing through the ebay.com, everything good. You like those gadgets, and you decided you wanted to buy it before you click it. You started to say that you're looking. How do you guarantee that this page is coming from actual eBay server? Not after the connection is established. We are talking even before the connection is established. I'm trying to connect to the page is being loaded. This page I'm looking at now. How do I guarantee it's actually coming from eBay? You can't guarantee. That's so. You cannot guarantee this page is coming from eBay unless you have some method of authenticating the eBay server. Now, the question is, who is going to provide such kind of authentication, or who is going to provide such kind of identity? Now, what normally happens is, let's say, I'll give you another example. Somebody comes to your home and says, I'm from so and so tax department, you have to pay so and so amount tax, so start paying it. Now what's the first thing you would do? Let's say somebody comes from a municipal department. They say you got a lot of property tax on hold, so we have come to check, verified everything. Take a look at your records. What's the first thing you would do? I'm expecting an answer here. Somebody walked at your door. He said, I'm from this office, so I want to verify all your records.
We'll
Yeah.
ask for them.
Authenticate. First, you say authenticate.
That's right. That's right. So we will usually ask for an ID card. Who are you? Why did you come to my house? Or, show me some kind of ID that proves you are from that department. Then I'm going to talk about the rest of the things, whether I paid or I not paid secondary. The first thing that comes to your mind, or all of you said, was you will authenticate that person. Now the way you are authenticating that person is by looking for a validation or some kind of identity. Now the same thing here applies. eBay.com. Now the first thing the browser might ask is, when the connection is established or before the connection is established, the browser asks, let's say, prove yourself that you are eBay. Now as long as you are browsing through these nice telephones, these gadgets, you are good. You don't ask for that verification. The moment you say buy now button, that's when you start thinking, am I buying from the right guy, or is my credit card information going to the right guy? Now when you have that validation point of view in your mind, means you want to validate at that point, then you're going to ask for some kind of identification. Now in a normal real world, we'll ask for an ID card kind of thing. Now who is supposed to provide that identity? It's the guy who is at your door, isn't it? Means if somebody says I am that person, that somebody is supposed to provide an identity card. Now the guy who is asking can ask for anything. Now here in the same case, the browser is the one that is asking, prove that you are eBay. Now it's eBay's responsibility to prove somehow that it's eBay. It has to provide some kind of identity. Now that identity in your programming world is called a digital certificate. So in this case, when eBay or when the browser has asked for a page, now the way of asking show me your ID is by sending a HTTPS request. If your browser is sending a HTTPS request, what the browser is basically asking is prove yourself, Mr. eBay. Now it's eBay's job to provide some kind of identity or some kind of verification card that the browser can validate. Now that verification card or identity card that we are talking is called a digital certificate. Now the digital certificate will be produced by eBay, and the digital certificate will be validated by the browser. Now before any communication starts, the purpose of validation is to establish trust. Means an identity card was given by the guy who is standing at your door. He is saying so and so. The identity card, you looked at it just like a browser looked at the digital certificate. Okay, you validated everything. So identity card, it says your name, you are from so and so department. So everything is fine. Now you have established what is called trust. Trust, and the second thing, identity. Identity and trust. This is the first part of SSL communication. Can you guys put yourself on mute? Anybody, can you put yourself on mute? There's a slight noise on the back. Thank you. So the purpose of SSL, if you observe it, we're not communicating any information at all between the browser and the eBay so far. The first request that you have sent is a HTTPS request, and the first question you're asking is prove yourself. then I will start communication. Then I will send my credit card information. So before you send any sensitive information to somebody, you want to make sure you are talking to the right guy. Now, that talking to the right guy, you're basically establishing an identity or verifying the identity of that server, and you are establishing trust. And this is the primary purpose of SSL. To validate the identity, establish trust. And this is done by looking at the ID card of the server, in this case eBay. The ID card in programming world is called a digital certificate. Now, so we point number one here, if you see, browser has asked the server to produce some kind of identity. The server has produced a digital certificate like identity card. Now the browser has some way of validating it. Let's say browser has validated. It has established trust. Now if you see the digital certificate produced by an eBay server, now sometimes in real world you will see, let's say you have written everything about your all your information of yourself on a piece of paper, and you have signed it by yourself. Let's say you said, my name is Anil so and so, I'm working at so and so company, and this is all my biodata. And okay, I'll give you a better example. Let's say a commissioner of police of your city came to you. You don't know his commissioner of police. He showed you an ID card. It says his name is so and so, designation commissioner of police for that city, department of police, and signed by that guy. He did show you that ID. Would you believe him? See, remember, the entire information in that ID is correct. You won't believe him. Why you wouldn't believe that guy? He's actually commissioner of police. All the information on the ID card is correct. Why wouldn't you believe? It could be fake. It could be fake. So if the ID card has all the correct information, but if it is signed by himself, that's right, he is certified by himself. If somebody signs the information by himself or herself, there is a chance that the opposite person is not going to believe. But the information was correct. Now, a digital certificate can also be something like that. It's called a self-signed certificate. A self-signed certificate is basically signed or generated by eBay itself in this case. eBay says, my name is eBay. I belong to ebay.com, eBay Incorporation. I'm holding it in so and so city, this country, this state. All the information, let's say, correct. But it was generated by eBay itself, and it's not certified by anybody else other than eBay. Now, if that kind of digital certificate, which is called a self-signed certificate, is produced to a browser, the browser may choose to reject that certificate. The browser may say, yes, you have given all this information, but the problem is you have signed it. I'm not sure if I can trust you. That's a problem. So a self-signed certificate, information is entire thing is correct, but it's not validated by somebody else. It's created by the server itself. Now, to make it much more authentic, what eBay can do is, let's say, now come back to the example that we're given. The guy who is saying he's police commissioner, which with his ID signed by himself, now he went to a government office or somebody which must an authentic guy. He got it signed by, let's say, the chief minister of our state. He got it signed by the Chief Minister. The Chief Minister signed it, stamped it, sealed it. Alright, now this guy came to us. He's shown the ID. Now he says, see, I got an ID signed by the Chief Minister. You can see all the seal of the Chief Minister, signature of the Chief Minister, everything. Now would you believe that ID? Would you believe that guy that he is a police commissioner? Yes. You would believe it because it's certified. You're saying this information on this card is verified by somebody that you trust. Not because the other guy who is certifying it is CM, but because you trust that guy. Okay, if I trust CM, if CM said this guy is police commissioner, it's right. So you want the identity or the digital certificate to be signed by somebody you know. Now the same case happens in case of a digital certificate also. Now the browser, I'm repeating again, the browser has sent a HTTPS request to the server. Now the moment HTTPS request is sent, it's basically a browser is asking, show me some kind of ID so that I can verify that you are actually eBay. Now eBay, instead of producing a self-signed certificate, it produces the same certificate but authenticated. Now this time it went to a CM guy called VeriSign. VeriSign verified all the information in the self-signed certificate. It authenticated, yes, whatever is on this ID card or whatever is on this digital certificate is completely genuine. Now that certificate has become a validated certificate, or the VeriSign which it went to is called a certifying authority. So eBay first has a self-signed certificate. It went to a certifying authority, CA, got all the information certified. Now the certificate that eBay is holding is called a CA certified digital certificate, just like your ID card signed by CM now. Now that ID card will be produced to the browser. How the browser will trust it? A browser has a list of authorities. If you see a browser, let's say, let me open Firefox. Every browser nowadays comes with a list of certifying authorities that it trusts. Means if a digital certificate is produced by a server signed by one of the guys in this list, look at this one. So here, privacy advanced certificates. If you go in here, view certificates, see this one, authorities. Now this browser has inbuilt list of authorities. If eBay produces a certificate signed by any of these guys, the browser is immediately going to trust that digital certificate. Now in this is the entire list of authorities, or the certifying authorities that our browser is going to believe. If any of these guys sign your digital certificate, my browser is happy. It starts thinking, okay, you got a digital certificate signed by one of these guys, so I trust all the information that you have put in. Out of all these guys, Entrust is a very popular one, and then you have VeriSign, the most popular of all. So you will see VeriSign somewhere down below. Yeah, here we go. VeriSign. So this is a list of certifying authorities that your browser trusts. Wells Fargo is also a digital CA. So we are looking at a list of certifying authorities that the browser trusts. Now any digital certificate that is not certified by companies in that list, the user will get a warning. The user might get a warning, see, we tried to ask the server to produce a digital certificate. The server produced a digital certificate, but we cannot validate that guy. So it's signed by some ABC, which I don't know. Maybe ABC is a very genuine guy, but I don't know that ABC guy. So here the communication, the first part of the SSL communication, what we are seeing is a browser asks for some kind of validation. A server can produce a self-signed certificate with a very high probability that the browser will reject it. The browser rejects, saying, I don't know, you have signed it yourself, so I don't know the guy who is signing it, so produce me something that I know about. Then the eBay went to a certifying authority like VeriSign, got all the information certified. It simply got authenticated. Certifying authority didn't do anything. They're selling their kind of trust that they established with everybody. Only thing is, if it is certified by VeriSign, we say okay. VeriSign says so, it might be good. That's it. Because you trust VeriSign. There's no other reason. There is nothing else that VeriSign is doing here. Now, the digital certificate that VeriSign signed is called a CA certified digital certificate. Now, that digital certificate will be produced to a browser. A browser in the list of its authorities has VeriSign as one of them. So, browser trusts eBay. So, browser has, what it has done is it validated the identity first thing, established trust. That's the first part of SSL. SSL is not to encrypt, SSL is not to do anything else. SSL is to validate the identity. That's the first and most important part of SSL. You are making sure you are talking to the right guy. That's the first part. Now there is a second part to this entire communication. So now you understood, or you ensured that you are talking to the right guy. But the talk that you are doing, or the message that you are sending, the credit card information in this case, it can be captured on the way to your receiver. Between your browser and eBay, there are lots of components, your routers, switches, and you can capture all the data packets from any of these elements. So obviously, not just talking to the right guy is not enough. Your message should be in such a way that it cannot be decrypted. That's the second part of SSL. First thing, you have established identity. You're sending it to the right guy. Now the second problem is, when you're sending it, you don't want anybody else to look at your information, look at your credit card information, which means your credit card number should be encrypted in such a way that it cannot be decrypted by anybody other than eBay. Now how do you guarantee that? We want to encrypt my credit card number in such a way that it cannot be decrypted by anybody else. Now that's when your Rsa algorithm comes into picture. SSL uses this algorithm. It's called Rsa algorithm. These are the three guys these are three mathematicians, Rivas, Shamir, and Edelman. These three are guys who have developed this Rsa algorithm. Then this Rsa was actually enhanced by another guy, which another mathematician. It became a DSA algorithm later. That guy's name starts with D something. So let's look at the gist of Rsa algorithm, what it says. Now Rsa algorithm says, you run my algorithm. These three guys are saying like this: you run our algorithm, it generates a key pair. The key pair, simply key 1, key 2. So let me just alright. Now what these guys are saying is, you run our algorithm, it generates a key pair. They don't say anything about public private keys. Rsa algorithm itself does not generate a public private key. It simply generates a key pair. Now what it say is, you can use any of these keys to encrypt. Only the other key will be able to decrypt it. Now these keys are very large numbers, let's say, a very large strings. They depend on that hash algorithm and all that stuff. Let's say they've generated large, very lengthy strings like with 1000 characters, 2000 characters. So what we are looking at is, you're looking at a key pair. Now if I use key 1 to encrypt my information, alright, what they say is, unless I have key 2, there is no way humanly possible to decrypt that one. So if I use K1 for encrypting some name, let's say there is a name, something like my credit card information, 1234 2345. This is my credit card, let's say. Alright, now I am using K1 to encrypt it. Then probably I'll get some jumbled number out of it. Some number. This is the encrypted information, let's say. Alright. Now what these guys say is, unless you have key 2, it is humanly not possible, or it's not possible with existing technologies. Now statistically it's impossible to bring it back to the original number. Statistically impossible means it would take years to bring back this number, this encrypted information back to this one. That's what their claim is, and that's actually true. And so far it usually takes years to get this number back without using K2. So obviously for somebody who is hacking it, or somebody who got this information, it's practically impossible. So the Rsa algorithm, just to repeat, what it says is, it generates a key pair, Q1, Q2. If you can use any key to encryption, the other key can only bring it back to the actual number or actual information. Without the key, it's practically impossible to get it back. They have proved that point. So it's something like, or else at least nobody was able to prove it so far. Nobody was able to write any algorithm that that brought back the original code without using key 2 in a reasonable amount of time. No algorithms. So SSL takes help of this algorithm. Now what SSL does is, it modifies it a little bit, or it uses a slight different notation of this one and takes users. The eBay server, which has produced a digital certificate, the digital certificate was signed by a certifying authority, CA, very signed. So when the digital certificate was produced, the purpose of the digital certificate was to establish identity or verify the identity, therefore establish trust. Let's say that part is done. So now the browser trusts, yes, you are eBay. Now let's start talking. Now when you say let's start talking, that's when the problem started. I'm trying to send you my credit card number, but I don't want anybody else to look at it. Then eBay gives a mechanism for that. eBay produces a key pair. Now when you have a key pair, you can encrypt with one key, other key only can decrypt it. So what eBay does is, it takes one key, calls it or gives it to the outside world. It says, you encrypt your information, send it to me, and the other key, it keeps it with itself. The key that is given to the outsiders is called a public key. The key that is kept with itself is called a private key. So remember here, there is a very clear distinction. It's not that public key is for encryption, private key is for decryption. There is no such thing. Any key can encrypt, the other key will be able to decrypt. That's how the Rsa algorithm works. Means even private key can be used for encryption. It's actually used, it's called a signature key. let's not go deep into it. So normally a key pair which is generated by Rsa algorithm, one key will be given out called a public key, one key will be kept with eBay called private key. Now in the digital certificate that was produced, there is a public key also. So eBay has a digital certificate certified by a certifying authority. In the digital certificate, it's not just the information that you have that your name is eBay, you belong to so and so company. If that information is trusted, there is also a public key of eBay. So the browser, what it does is first validates that it's eBay. Okay, fine, it's eBay. Then the trust is established. The third part, or the encryption part, it takes the public key of eBay, encrypts the credit card information. So here in this case, if you take it, another example that we've seen, your credit card information is encrypted using the public key of eBay. Just give me this. This one. Now when that credit card information is encrypted with the public key of eBay, that will be sent back to the browser. Yeah. See this one. Step 4. Step 1. If you look at the yellow box here, a browser, you hit the eBay URL using HTTPS. Here there is no HTTPS, it has to be HTTPS here. So the eBay server has produced a CA certified digital certificate. Now browser validates it, the trust is established, and this is the information you will see in the digital certificate, typical information. Information of eBay server in plain text, the same information in encrypted format by VeriSign, the public key of VeriSign, the public key of eBay. Now once the trust is established, a browser uses the public key of eBay, sends the information. Now the eBay uses the private key to decrypt the information, so eBay has your credit card information. So that way, this is this screenshot. I would like you guys to look at this screenshot later, because actually this is actually how a browser validates the CA signature. Means let's say CA certified it. It's like, you looked at the identity card of the police commissioner guy who came to your house. He's saying it's certified by CM. The first thing comes to your mind is, what's the guarantee it's actually CM signature? How do you validate its CM signature? You're not going to blindly believe, okay, CM signed, it's CM, this guy is police commissioner, right? You are going to validate that's actually authentic signature. The same way your browser also tries to validate that the signature on the digital certificate is actually of the VeriSign. Now that validation is actually this flowchart that you are looking at. It's a very simple technique that a browser uses. Let's say here, info of eBay server in plain text. This is a part of a digital certificate. Let's say my name is ebay.com. Let me go back here. I'm coming here. We are looking at this diagram, this scenario. Browser has hit HTTPS. That is step 1. eBay server has produced a CA signed digital certificate. Step 2. This is the digital certificate we are looking at with all these 4 pieces of information. Now the browser has to validate these 4 pieces of information, and it should say, okay, this is actually signed by VeriSign. Now how the browser is going to validate that? This is a flowchart. Look at this one. If you see the first piece of information, info of eBay server in plain text. For the sake of simplicity, let's say we are taking ebay.com is the name that was put in. It says my name is ebay.com. That's information 1, or the point 1. Now when it went to a certifying authority, VeriSign certified, yes, this guy's name is eBay.com. But that information was actually signed by the private key of VeriSign. Remember this one. This was encrypted using the private key of VeriSign. So eBay.com is a name. I think it gets little confusing here, so I'll draw a diagram. So a self-signed certificate has, it says, my name is eBay, ebay.com. Now this information is signed by the private key of VeriSign. Remember, when you went to VeriSign, you're getting it signed with a private key of VeriSign. So let's say here, now you got some random numbers here. So here ebay.com was converted into some random text. Alright, so you got this random text because VeriSign used its private key. Now how do you get it back to ebay.com? The ADSF23 string, if we have to get it back to ebay.com, what's the key I would need? Come on guys, what is the key that I would need?
The private key.
The private key. That's right, the private key of VeriSign. Now hold on, yeah, this is gone. I don't have my mouse today, so I forgot it at my office. Okay, this is ebay.com. Alright, we have encrypted this information with VeriSign private key. Now after encryption, I got this some random text. Alright, or some numbers, let's say. Now if I have to encrypt, or if I have to bring it back to ebay.com, I would need VeriSign's public key. VeriSign's public key. This is what I would need if I have to bring it back to the original eBay. Here in this direction, VeriSign public key. So this piece of information that you are looking at, this information and this information, both will be put into the digital certificate. Remember this diagram, so I'm going to save it. Control-C. VeriSign. Alright, so what we are looking at is eBay in a plain text. That's the first piece of information. Then the 123 string, which we got by signing ebay.com with the private key of VeriSign. So if I have to convert 2 to 1, all that I need is a public key of VeriSign. Now that's what a browser uses. Look at this next step. Browser gets the digital certificate. It decrypts 2, means the 123 string, using the public key of VeriSign. Alright. So the public key of VeriSign is used to decrypt information 2. Now how can I decrypt? Okay, if I decrypt information 2 with the public key. If it matches with 1, means ebay.com, it means now the only way you can bring it back to ebay.com is by using the public key. If I'm using the public key and bringing back to the version 1, it means it is actually signed by VeriSign. If after the decryption, if I decrypt 2 but I did not get ebay.com, it means my signature is wrong, isn't it? Did you get that point here? How a browser validates the signature. Yes, no. Let me put it here. That's a very actually smart way a browser does. Excellent. So if all of you got it, it's very nice. That's the most critical point of SSL. How a browser knows that it's actually signed by VeriSign. This is how a browser knows. Browser is using the public key of VeriSign, and unless the second piece of information is actually signed or actually coming from VeriSign, there is no way by using the public key of eBay it can get the same information as 1. That's how a browser knows, okay, this is signed by VeriSign. Once it identifies, okay, this is signed by VeriSign, then it knows if it is signed by VeriSign, I can trust it. It's like you're authenticating the signature of it. You trust CM, no issues about it. You trust VeriSign. But what you are validating it, is it actually signed by VeriSign? That checking, this is how a browser does. Now once that is done, obviously your browser is going to go to the Rsa algorithm. The Rsa algorithm basically ensures that nobody else can decrypt your credit card information unless they own the private key. Now in this case, we're going to use the public key of eBay, then encrypt the credit card information, send it to the server. The server will be able to decrypt it. Alright, so that's the fundamentals behind SSL. So just to summarize, SSL does two important things. One is, the first point is identity and trust, and we are doing identity and trust using a digital certificate. So a digital certificate will be produced by the server. A digital certificate will usually be a CA certified digital certificate. That identity or the certificate will be validated by the browser, just like we've seen just now. If the validation is done, trust is established. Once the trust is established, your browser uses the public key in the digital certificate, the public key of the server. The public key will be used to encrypt the information, will be sent across the network. Only the holder of the private key, in this case the server eBay, will be able to decrypt it. So identity trust is the first part, encryption is the second part. Now this is not just between a browser and a server. We have been talking about browser and server, but the same type of communication can be established between any two applications. Two Java applications, like I think Chana, you were asking, is it only for client and server? No, it's not necessarily for client and server. It can be between any two applications. SSL is usually called transport layer security. Means when you are transporting your messages, that's where it provides security between two applications when they are talking to each other. It allows both of them, it allows one guy to authenticate itself, and it also allows to securely send the information. Now the one that we've been talking here, a browser asking the certificate to the server, is called a one-way SSL. At a later point of time, means once the identity of the server is established, the server can also ask for the identity of the browser. Means the server may ask, prove yourself or authenticate yourself who you are talking to me. In that case, the browser should present a certificate to the server. The same process goes on. In that case, your browser should have some kind of certificate configured to be presentable to the server. Now that kind of communication is called a two-way SSL. So there is one-way SSL, two-way SSL. One-way SSL is the guy who is sending the information authenticating the guy who is receiving it. That's one way. If the guy who is sorry, I think I put it in sending and asking and replying, let's put it that way. A guy who is asking the information authenticates the guy who is replying. That's one way. If the guy who is replying also wants to authenticate the guy asking guy, it will be a two-way SSL. Now, as you've seen, SSL is, it takes a toll on your performance. If there is no SSL, usually you will have browser asks for it, eBay server gives it. That's it. One or two steps. All right. One go, ask it, request response. Only one side, second. But the moment you have SSL implemented, there are too many steps. Browser first asks for a digital certificate, step 1. eBay produces a digital certificate, step 2. Browser validates it, step 3. Encrypts the information, step 4. Sends it, step 5. eBay decrypts it, step 6. And eBay responds, step 7. Means what usually is a 2-step process, now converted into a 7-step process because of SSL. So SSL degrades your performance seriously. So even now, because of that reason, obviously you don't want SSL unless you really need it. In this case, not every page is SSL. If you see some of the pages, they are probably not SSL. See this one. This is not SSL. There is no SSL. I mean, so we don't really care if we are talking to eBay or not. You're not sending any sensitive information here on this page. The moment you click on a buy button, that's when your verification starts. Which means not all areas of a website or not all areas of an application need to be done in SSL, because you don't want to implement SSL unless you are sending critical information. Now only when you are paying the money, only when you are sending your credit card information, that's when you will send a HTTPS request. So if you are browsing on eBay, probably after your shopping cart is filled and then you click on pay now button, that's where it will be linked to HTTPS, and that's where the validation starts. Not on every page, which means an application communication need not be in HTTPS in all URLs, in all areas. Only in certain areas where you are sending critical information, you would like to implement SSL. Alright, now you got an idea of what is an SSL, why we use SSL. Now the next thing is how to implement it. It's how in real world, or how in your programs it gets implemented. Any questions here so far? It's a very nice topic. Not many people really understand SSL, but if you do, it's going to be a lifetime concept. Cool. Okay, now in that case let's look at, we'll briefly go through how we implement it in real world. Now the certificate generation, the self-signed certificate. Yes.
So we have seen some third parties verification, like VeriSign, which are stored in the browser. If it's not a browser, let's say application to application communication. So
you will have a CA certs file. There will be a CA certs file that comes along with your JDK. Now that will have all the CA certs. You will see it in somewhere else here. This is your BA home. This is JDK. Find that CA certs file. That file. This file will have all authorities.
Okay.
This if it's between application to application, your first application is going to use the CA sets file, CA certificates there.
Hello.
Yes.
Hi sir, this is Kalyan. And even in the application to application communication also, the same process will continue, right, sir?
Same process, no changes.
As like in client and browser, right? Sorry, client and the server.
Yes, that's right. Same communication, it doesn't change. Any two applications talking to each other, one guy asks for a certificate, other guy produces it. First guy validates it, trusts it, encrypts information, sends it, the other guy decrypts it. Same.
Okay. So like my question is like when they are on like the same server, when they are like deployed in the same server, suppose two applications, and where they will like store the digital certificates, like one application asks for like a digital certificate, and the second application will provide it, and even though the first application also will have its digital certificate, if it is like a two-way SSL configuration, like where do they store the certificates?
We'll come to that point. We'll come to that.
Okay.
We'll come to that in implementation. Okay. So now what we are looking at is how to implement this entire thing. Means how to create a self-certificate. Let's say you are the eBay administrator. You are the eBay administrator. You have been asked, okay, let's set up a SSL certificate so that when our customers are browsing through the browser, when they hit that HTTPS or the pay now button, a browser will try to validate our server. So you are the eBay administrator. Now you have been asked to set up the SSL, which means you have to generate a self-signed certificate first, get it signed by a certifying authority, then configure that certificate for your eBay server, so that when somebody asks for a certificate, your eBay server can produce it. So this creation of a self-signed certificate, getting it signed by a very certifying authority, all these things are done by what is called a key management tool called Keystore. Now this comes with all your JDKs. For example, the JDK that we have installed. So here, this is a JDK, and a JDK bin, you will have a key tool. This is a key management tool. This is one key tool. There is another key management tool called OpenSSL. I'm not sure if it's here. Yes. OpenSSL is another key management tool, open source. Whereas a key tool is a Java-based key management tool. So usually you can use any of these two things, a key tool being more popular one. Alright. Now if you understand one, you will understand the other one also automatically. You don't have to really worry about it. So we will be concentrating on the key tool because that's what you will be using most of the times. Now what key tool allows you is to generate a digital certificate and give you a mechanism to get it signed by a certifying authority. It allows you to create a storage area where you can store these digital certificates, because digital certificates are sensitive information. Then obviously you have the public-private key pairs. They have to be stored. Now all these things are usually, if you see, are stored in what is called a Java Keystore, which gets generated using a key tool command. Now the Java Keystore is what you are looking. In Java Keystore you have lots of entries. Each entry is called an alias, and each alias is basically a digital certificate plus public-private key pair. Means all the servers digital certificates, means each server, let's say in eBay, can have a digital certificate. All of them can be stored in a Java Keystore. So whatever digital certificates you have, they can all be put into, like, Keystore is a basket kind of thing. You can put a digital certificate plus the public-private key of eBay server in this case into the Java Keystore. If you have another server 2, that will also have a digital certificate plus public-private key, you can put it there. That's called entire thing. This entire thing is represented by an alias. The same way you can have server 3 that will have a digital certificate plus public-private key. Alright, that's called an alias. It can be put into a Java Keystore like that. Alright, so your Java Keystore creation, your digital certificate creation, your public private key generation. Apart from this, sending this digital certificate to VeriSign for getting it signed, all those things can be done or can be managed using the key tool. Now, using some of these options that we're going to discuss. So a key tool is usually the key management tool. Alright, now we're going to see how to generate how to create a Java key store, how to generate a digital certificate, how to generate a public private key, and finally how to configure that digital certificate to the server. Alright, so we'll see these things in tomorrow's session. That will take an entire session end to end. By the time we finish that session, you will be able to configure, or you will be able to generate a digital certificate, get it signed by a certifying authority, import it back into the Java key store, configure that certificate to your WebLogic server, and then when somebody asks your WebLogic server to identify itself, it can produce a digital certificate that you have configured. Alright, so we'll stop it here for today. That will be halfway even if we start now, and we will